So, isotopes. Isotopes are atoms of the same element that differ in their number of neutrons. I saw this popping up a lot, that a lot of people were confusing protons and neutrons. So in order to talk about this, we're going to use the building an atom simulation. The first example that they give you for isotopes gives you these three different types of hydrogen. And I can show you here, if I throw in a proton and I throw in a neutron, that is our typical hydrogen atom. Atomic mass of 1, atomic number of 1 electron makes this a neutral atom. Cool. So if we put in a neutron, hydrogen stays hydrogen. The atom stays neutral because neutrons don't have a charge, but our mass number went up by 1. When I add in another, it becomes unstable, okay? That just refers to like nuclear chemistry, radioactive decay, which we're going to cover toward the end of the year. It's not as important right now. What is important to know is that these unstable nuclei do have a function. A lot of times we use them for various medical research purposes, health purposes, carbon dating, things like that. We're not going to get super deep into that right now. I really want to talk about the nitty gritty of what makes an isotope and what doesn't make an isotope. So we had this reading about isotopes. We also had this assignment and more specifically, this exit ticket. So this exit ticket used to be a multiple choice question, but I turned it from a multiple choice question into several short answer responses. So you have to look at each pair here, pair 1, 2, 3, and 4, and tell me, are these isotopes, is each pair an isotope or not? So, real quick, definition, atoms of the same element that differ in their numbers of neutrons are called isotopes. So same element, different number of neutrons. So if we look at this guy right here, we have 121 SN, SN is tin, and 119 SN. So my simulation doesn't go all the way up to 119, so I'm going to approximate this with beryllium. So I have beryllium with 4 protons and 5 neutrons. I have beryllium with 4 protons and 5 neutrons. I want to make this a neutral atom because there's nothing here saying that it's not a neutral atom, so I'm going to assume that it is. Okay. So we have an atomic mass. We have a net charge of 0 on both of these. We have an atomic mass on both of these. So in our practice problem, they did not have the same. So I'm going to take one of these neutrons away. All right. So now we have beryllium 9 over here and beryllium 8 over here. Are they both neutral atoms? Yes. Are they both beryllium? Yes. Do they both have the same number of protons? Yes. Do they have the same number of neutrons? No. These two things right here are isotopes because they're the same element, but they have different mass numbers. Okay? If we look at the second problem, second question, it's a 121 tin and 121 tin. So I can approximate that by making my mass numbers equal. All right? If my mass numbers are equal, these are no longer isotopes because they no longer fit the definition. Atoms of the same element with different masses. They don't have different masses. They're no longer isotopes. These are just identical atoms. They're just identical atoms. That's all. That's all. I also saw some people get mixed up on these questions, 3 and 4, where they would see that chlorine and potassium have the same mass. Well, I can just approximate that too. So here we have 2 mass numbers and 9. All right, I'm going to take out a neutron and put in a proton. So I have neutral atoms, mass number 9, but our protons are not the same amount. They're not the same atom. They're not the same element. As soon as our protons are different, we have a different element. The name of the element is here, beryllium for 4 protons, boron for 5 protons. I think that's another thing that we are struggling to embody in its entirety, is that idea that if an atom has the same number of protons as any other atom, those atoms belong to the same element. The protons make the element, not the other way around. A lot of times people will use the term atom and element interchangeably. Atoms and elements are not the same thing, okay? We cannot use those terms interchangeably. Atoms refer to the structure. Atoms refer to a nucleus with electrons surrounding it. An element refers to the exact number of protons that an atom has. So if you're saying the elements have the same number of elements, which I saw kind of a lot, that's a circular statement. That doesn't mean anything, right? The atoms have the same number of protons. The atoms have the different number of neutrons, right? Atom refers to, it's like referring to all cars as Hondas. Like not all cars are Hondas, right? Cars refer to, we have a body, we have 4 wheels, we have an engine, right? Like an atom means that we have protons, neutrons, and nucleus, electrons. An atom can be beryllium, an atom can be boron, an atom can be carbon, just like a car can be a Honda, it can be a Chrysler, it can be a Mitsubishi or whatever, right? The structure retains the same, but the fine differences within it determine what element it is. So I think that's important to think about when we talk about isotopes, is the difference between atoms and elements. Atom is the structure. Element is determined by how many protons we have, all right? Important to remember.